All right, the rock cycle. The Himalaya mountains are eroding at a rate of about 2.5 millimeters per year. That's about 1/10 as fast as your fingernails grow. But the Himalayas were formed millions of years ago. So imagine the total mass of rock that has fallen down the mountain and that has been swept out to sea. Over millions of years, the piled weight of eroded particles will squeeze the bits together on the seafloor. New rock will form, then ancient bits of the Himalayas will be recycled inside new rock. How could small pieces of the Himalayas form new rock? All right, what is the rock cycle? Natural forces act on the Himalayas. In fact, rock in Earth's crust is always changing. Forces deep inside Earth and at the surface produce a slow cycle that builds, destroys, and changes the rocks in the crust. The rock cycle is a series of processes that occur on Earth's surface and in the crust and mantle that slowly change rocks from one kind to another. For example, weathering can break down granite into sediment that later forms sandstone. One pathway through the rock cycle. There are many pathways by which rocks move through the rock cycle. For example, Stone Mountain near Atlanta, Georgia is made of granite. The granite in Stone Mountain, shown in Figure 1, formed millions of years ago below Earth's surface as magma cooled. After the granite had formed, the forces of mountain building slowly pushed the granite upward. Then, over millions of years, weathering and erosion began to wear away the granite. Today, particles of granite constantly break off the mountain and become sand. Streams carry the sand to the ocean. What might happen next? Over millions of years, layers of sand might pile up on the ocean floor. Slowly, the sand would be compacted by its own weight. Or perhaps calcite, that is dissolved in the ocean water, would cement the particles together. Over time, the quartz that once formed the granite of Stone Mountain could become sandstone, which is a sedimentary rock. Sediment could keep piling up on the sandstone. Eventually, pressure would compact the rock's particles until no spaces were left between them. Silica, the main ingredient in quartz, would replace the calcite cement. The rock's texture would change from gritty to smooth. After millions of years, the sandstone would have changed into the metamorphic rock quartzite. Number the materials that move through the rock cycle at Stone Mountain in the sequence given in the text. So sand, granite, and quartzite. All right. As shown in the photograph, trees can grow on the mountain. Their roots might break up the granite. What step of the rock cycle do trees play a role in? And then, does the rock cycle stop after the quartzite has formed? Explain. All right, the rock cycle. How do rocks form? Through melting, weathering, and erosion, and heat and pressure, the rock cycle constantly changes rocks from one type into another. Study the diagram, then fill in each blank arrow with the correct term. Melting, weathering and erosion, or heat and pressure. Hint, to fit your answers, abbreviate weathering and erosion as W and E. So you're going to be placing those in this diagram. All right, the rock cycle in action. Processes that are happening deep inside Earth cause the changes that occur in the rock cycle. If you could peel away Earth's top layer, you would discover that Earth's surface is broken into several pieces called plates. These plates move slowly, pushed by currents that first rise towards the surface and then sink back down again like a slow-moving whirlpool. It is these plate movements that help drive the rock cycle. How? They play a role in forming magma, a molten material found deep below Earth's surface. It is this magma that is the source of igneous rock. Where plates move apart, magma formed from melted rock can move upward and fill the gap in the plates with new rock. Where a plate is pushed beneath another plate, magma forms and rises. The result is a volcano made of igneous rock. A collision of plates may push rocks so deep that they melt to form magma, leading to the formation of igneous rock. Sedimentary rock can also result from plate movement. For example, the collision of plates can be strong enough to push up a mountain range. Then weathering and erosion begin. The mountains are worn away. This process leads to the formation of sedimentary rock. Finally, a collision between plates can push rocks down deep beneath the surface. Here, heat and pressure could change the rocks to metamorphic rock. Conservation of material in the rock cycle. Constructive and destructive forces build up and destroy Earth's land masses. But as the rock in Earth's crust moves through the rock cycle, material is not lost or gained. For example, a mountain can erode to form sediment, all of which can eventually form new rock. All right, apply it. New rock forms on the ocean floor at the mid-Atlantic ridge. Here, two plates move apart. Number 1, igneous sedimentary rock form at point A, so circle which one. 2. How can rock that is formed at the Mid-Atlantic Ridge be changed into sedimentary rock? All right, and then assess your understanding. The rock cycle builds, destroys, and changes the rock in Earth's crust or core. How do rocks form? Mind your minerals. Suppose your teacher provided you with the 4 unknown mineral samples labeled A through D below. Each sample is a mineral from the complete list of minerals that are included in the Mohs hardness scale, which was discussed on page 294. Students must use the objects from the chart to the right to determine the hardness of the unknown mineral samples. Students can then identify the minerals using the Mohs scale. All right, over here. Think about how you could determine the hardness of each sample and use that information to identify each mineral. First, write the steps you would follow in the procedure. In each step, be sure to explain what you will do, what equipment you will use, and what observation you will record. Use the following information to complete the data table by writing yes or no for each sample. The edge of the penny scratched only sample A. The iron nail scratched samples A and C. The pocket knife scratched every sample except B. The steel file scratched all samples. Okay, then for number 3, suppose the teacher tells you that the samples each have a hardness of 3 or higher. Determine the hardness of each mineral sample. Then use information from Mohs hardness scale on pages 295 and 294, or 294 through 295, to identify each mineral sample. Write the name of the sample on the line below each photograph on this page.